Learn how to use the data view to mix and match different numerical data types inside a single array buffer by micromanaging exact byte offsets. So here's my boilerplate code, and we want to look at how we can use data view for advanced memory control when working with array buffer. Now, if you noticed something about this array buffer, even though you can use things like uint8 array and int32 array to lay data, to lay views on our array buffer, it follows a strict rule where every single slot has to be the exact same size. It's either it's 8 bits or 4 bytes or 8 bytes of data. Any other thing from that will give a range error. But what if you need to pack a massive 32-bit index and then a small 16-bit status code right next to each other in memory? How do you do that? With int32 array and u8 integer array, there is probably going to be a problem because it will be almost impossible to be done. But with data view, a data view is the ultimate flexible lens that doesn't care about rigid grid slots. So instead, it lets you reach into any specific byte location and drop in whatever size number that you want. So let's look at an example that actually depicts how data view works with array buffer in JavaScript. So I'll go ahead and allocate 8 bytes raw binary memory buffer. Allocate 8 bytes raw binary memory buffer. So how am I going to do that? Just make a variable, call it my buffer, and then call the new array buffer and assign it past the 8 bits as a slot into it. Now that I have done this, it's now time for me to create a data view to manipulate the buffer. And how do I do that? Well, it's very simple. Just make another variable, call it view, and now this time just call data view as well. Call it with new data view as new data view constructor, and then pass in your buffer, which is what I just did here. So now let's write it as 2-bit integer. So our buffer. So how do I do that? Well, I'll call my variable name and call set int32. You can see it that this thing is referring it that my editor is popping it up for me, and it's a method. You can see it's method here. Store an integer 32 value as the specified byte offset from the start of the view. So I'll click on it, and in my own case, I want this count to be at 0, the starting point, and then let's say I give it an endpoint of this. That is offset at 0 and value of this. So now that I have done that, I can also combine something else. So I can then skip ahead to like maybe byte offset 4. And at this byte offset at 4, I want to write a 16-bit integer. So how do I do that? Well, I'll call my variable name again and call this set integer 16. So because my byte offset is at 4, that is going to be what I will pass. And another value, let's say 32,000, to be the value of my offset. So I'm good to go. Now, it is time for me to now read the value back out. Read the values back. And how do I do that? Well, let me make a simple variable. And let me assign the first one to it. But this time around, you can see that what I did here is I am writing into my view set integer. So now that I've finished writing into this, it is time for me to read. And how do I read? Then I'm going to need another method which is called get integer. So the first one will get 32 at an offset of 0. The second one will get 16 at an offset of 4. Therefore, I can go ahead and display the results. Document.getElement by ID demo.next was values are plus v1 plus space and plus v2. And now you can see values are 1, 2, 3, 4, 5, 6, and 32,000. So this example shows us how a single 8-byte array buffer can be split irregularly. You can see we split it into 32 bits and into 16 bits. So we use a data view, which is what we have here, to write a large 32-bit integer across the first 4 bytes, offset 0 to 3, and then immediately drop a 16-bit integer into the next 2 bytes, offset of 4 to 5, which is what we have here in my code. So the byte offset sets is simply that instead of using standard index position like view1, a data field uses explicit byte address. Pointing a method to 4 means you are targeting the exact 4 bytes that the memory pipeline. Now, the explicit type method, which are setInt that you see here and getInt that you can see here, you declare your data type on every single action using clear semantic command, such as setInt and getInt, as you can see. Now, why use a data view instead of just making multiple types array over the same buffer? Well, network packet and binary file formats, like for example, custom image or audio files, they are often saved using different byte ordering rules known as endianness, that is big endian versus little endian. So standard type array are forced to use whatever format your computer hardware prefers. But a data field has a massive advantage. It accepts an optional Boolean flag as a final parameter to toggle between byte orders manually. So this is absolutely mandatory if you are decoding binary file upload or talking to network server.